We have moles infesting chemical equations. Now, he tells us very clearly, like we said at the beginning, we are looking at recipes. And so here we see that in a balanced chemical equation, the coefficients before each molecule actually tell you how many molecules there are there or how many moles there are there. And that pink box says a chemical equation gives the amount of reactants and the products in moles. And so that's a conversion relationship that we can use. And you see in the example problem how when he breaks down hydrogen peroxide into water and oxygen, for every 2 moles of hydrogen peroxide, you get 2 moles of water and 1 mole of hydrogen peroxide. And that is your relationship between these. And so we can use that as a conversion factor to get from whatever you start with to wherever else you want in the problem through the mole bridge. And so you see there that he started with 12.8 moles of hydrogen peroxide, and he went ahead and went through the mole bridge and figured out how many moles of water that would produce. And he can do the exact same thing you see on the top of page 206. He can do exactly the same thing with the oxygen. And so you can go back and forth. That's what's so powerful about stoichiometry is that you can go back and forth between any things in a balanced chemical equation and find out those quantities. Now, let me work an extra problem from these, from the extra practice problems on these to maybe help you. The extra practice problems, the first one, it says 100 grams of silicone, and we're supposed to determine how many moles that is. So we have 100 grams of silicone, and we want to know how many moles. You're going to go times line, whatever's here has to go here, and we're trying to get to the moles of it up here. We know that in 1 mole we have to go to the chart, and when we go to the chart, silicone, its mass is 28.09. 28.09. And then we have 4 significant figures here and 4 significant figures here. So our answer will be in 4 significant figures. So 100 divided by 28.09 equals, we have 4 significant, 3.55. Wow, I got 998. So I'm actually going to go to 3.560 moles of silicone. And let me show you once again why I did that. 3.55998. Okay, we need to go to this place, don't we? But this number's a 9, so this is going to roll up. So the roll up, that has to turn to 60, doesn't it? But here we still have 4 significant figures. So I just wanted to show you why that answer came out that way, because you had to go here, and that rolls that 9 up, so then you'd go to 60. All right, let's try the next one. The next one is 150 grams of water, and we're going to figure out how many moles of water that is. 150 grams of water. We want to know how many moles. We know before we do anything else, we're going to put that down here, and we're trying to get to the moles of water, so we're going to put that up here. We know that in every 1 mole, we can add this up, can't we? So we're going to go 2 times whatever hydrogen's mass is, which if you look on your chart, it's 1.01 grams, plus, look on your chart for oxygen, it's 16.00 grams, which is 18.02 grams. You probably have that one memorized by now, if you've done all these problems. And so we have 4 significant figures each place by 18.02, and that gives me, I need 4 significant figures in my answer, so 8.34, excuse me, I can write, 8.324, and the next digit is a 0, so I'm in good shape. These leave, so I'm left with moles of water. That way I know that my numbers are in the right place because my dimensions come out correctly. The next one is 500 grams of glucose. So we have 500.0 grams of glucose, C6H12O6 times line. We want to know how many moles, so we're going to put grams of glucose down here. and moles of glucose up here. We know that in every 1 mole, we have 6 carbons. You look up carbon and it's 12.00 grams. Just going to make sure. Oh, it's 12.01. There you go. Plus 12 hydrogens. You look that up. It's 1.01 grams. Plus 6 oxygens, which is 16 grams. That gives us 180.18. 180.18. So we have 5 significant figures there, 4 there. Remember, we just take it to the hundredths place because they all go to the hundredths place. That's why we ended up with 5 here. So we go 500 divided by 180.18 equals 4 significant figures, 2.775. The next digit is 0, so I'm in good shape. Moles, the next digit in my calculator, of glucose. So there we have the moles of glucose. Let's do the other way. And we start with moles and we can figure out how many grams. So we are given 5.41 moles of sulfur, and we want to know how many grams. So we're going to go times line, moles of sulfur, grams of sulfur, and every 1 mole, you look on your periodic chart, it's 32.06. This will cancel, so we're going to go 5.41 times 32.06. That gives us 4, I got 3 significant figures here, so I'm only going to have 3 in my answer, and that's grams of sulfur. Okay, let's do the next one. Without breaking your thing. Let's do the next one. The next one is 0.12 moles of potassium chloride. Now, you guys can stop this and do it yourself. Try it yourself and see if it works. I'm just trying to help. Times line. Whatever's here always goes down here. And we're trying to get to grams of potassium chloride. And we can do grams to moles of the same thing. 1 mole, we're going to add this up. So we're going to look up potassium. Potassium is 39.10 grams. That's the potassium. And then the chlorine, we looked that up. We have 1 of those, 35.45 grams. And so that's going to give us 74.55 grams. So I put that in here, 74.55 grams for every mole of that. So then I'm going to, good. 4 significant figures here, 2 here. So our answer has to be in 2 significant figures. And so 8.946 comes out of my calculator, but I need 2 significant figures. The next number is a 4, so it leaves. And then these gone, so you're going to have grams of potassium chloride. I just want you to know I much prefer to teach this with you students here. Just want you to know. Let's see, let's do the next one. The next one is 1.761 moles of ethanol, C2. That will help. H6O. All right, and we're trying to get to moles, grams from the moles. So I put moles of this down here, and I want grams of this up here. I know in 1 mole I can figure out the grams. 2 times carbon, which is pretty sure 12.01. Okay, 12.01. I think I messed that up in the last one, didn't I? Plus 6 times hydrogen, 1.01 grams. Plus 1 oxygen, 16, equals. Okay, so we have 12.01 times 2 plus 6.06 plus 16. I get 46.08 grams. 46.08 grams, okay. And now I'm going to take that and multiply it, 46.08 times 1.761. And I have 4 significant figures here, 4 here, so my answer will be in 481.1. And then what I got is 46, and I have to go to here. So I'm going to roll that 4 up to a 5, because you always look at that digit just past it to see whether you're rolling up or down. You can underline it if you need to, and that'll help you to see. Okay, let's try something else. Number 3, it says how many atoms are found in 50 grams of magnesium. So we want to know how many atoms are there in 50 grams, write significant figures. Oh, excuse me, 500 grams. Got the decimal off completely, didn't I? 500 grams of magnesium. Okay, so this way I know what my given is and where I'm trying to get to. Now I know if I go to moles, I can figure out how many atoms there are, can't I? So I go times line, whatever's here always goes down here because that's the only way it's going to cancel. And I'm going to go to moles of magnesium because I know how to do that, don't I? So in 1 mole, I look at my chart. Magnesium is in group 2. It's 24.31. Here we go. So we go 500 divided by 24.31 equals. That gives me 20, let's see, 4 significant figures. This gives me 5, 6, 7, da, 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 da. We have to go to the 6, so I'm going to show you. We have to go to the 6 with 4 significant figures, so I'm going to round that up to 7 because the 7 that was behind it. And this is moles of magnesium. Now from that we can figure out how many atoms, can't we? Because I'm going to rewrite it over here so I have room. 20.57 moles of magnesium times line. You know whatever's here always goes down here. And now we want to get to atoms, not molecules, I'm sorry. Atoms of magnesium, don't we? Well, we know in 1 mole we have memorized 6.02 times 10 to the 23rd atoms or molecules, depending on what you're dealing with. And so we go ahead and we take our 20.57 and multiply it by 6.02 EE 23. In my calculator, that's how you do it. I need 3 significant figures in my answer. What comes out of my calculator is 1.238, blah, blah, blah. I've got to go to here. So that 8 is going to round that up to a 4 times 10 to the 25th atoms of magnesium. This will cancel. Yep, there you go. So that's how you would do that. So you start with your given, put whatever's here down here, go to your moles. Then from the moles, we can very easily go to the number of atoms. What do you have to have memorized there? You have to have memorized the molar relationship, that in every 1 mole you go to the chart to figure out what its mass is. You also have to remember that in every 1 mole there's 6.02 times 10 to the 23rd atoms or molecules, depending on what you're working with. So you have that memorized, and that helps you to work with this. Number 4, how many molecules exist in 10 grams of aluminum chloride? So we want to know how many molecules, and we're starting with 10 grams of aluminum chloride. There we go. So we're going to go times line, grams of aluminum chloride, and we need to go to moles of aluminum chloride because we can't just put molecules up there. We don't know that. So you can't make 1 step there. You have to make 2 steps. With every 1 mole, we're going to add this up. We're going to look at your chart. Aluminum is in group 3. It's 26.98, 26.98, and there's 1 of them, plus 3 chlorines, which is 35.45. 35.45 grams. There we go. So we're going to go 3 times 35.45 equals plus 26.98 equals. We go to the hundredths place because we're adding or subtracting. And so that's what came out of my calculator. So now I can stick this in here. 3.33. A lot of 3's there, huh? And so now we can go 10 divided by 133.33 equals. And we need 3 significant figures in our answer because there's 3 here, 4 here, 5 there actually. So 0.070, excuse me, 0.0750. I was trying to get in the 3 significant figures. Here's your 3 significant figures. And this is moles of aluminum chloride, right? And we want to know how many molecules, so we've got to go a step further, don't we? So we're going to take that number, 0.0750 moles of aluminum chloride times line. We have the moles of it down here. We have the molecules of it up here. And every 1 mole, there's 6.02 times 10 to the 23rd molecules. So we're going to go 0.0750 times 6.02 EE23 gives me, in 3 significant figures, 4.5, and I've got 1 5. So I'm going to roll this up to 2 times 10 to the 22nd. Always look 1 past molecules of aluminum chloride. Number 5, a chemist has 5.0 times 10 to the 25th molecules of ammonia. And he wants to know how many moles that is. So we're going to go to how many moles that is. So I'm going to go times line. And I know that whatever is here has to go here on the bottom. And I can get straight from molecules to moles, can't I? I sure can. And every 1 mole, I know there's 6.02 times 10 to the 23rd. So I'm going to take that and go 5 times 10 to the 25th divided by 6.02 EE23 equals, and that gives me in 2 significant figures, right? 83 moles of ammonia. And then the next thing he asks is, how many grams is that of ammonia? So we know we have 83 moles of ammonia, so we're going to take that 83 moles of ammonia, and we're going to go to grams. Take this, put it down here. Put grams up here. One of these, we're going to add this up. We go look for nitrogen. Nitrogen is 14.01 grams plus 3 times hydrogen, which is 1.01 grams. And that's going to give us 17.04 grams of nitrogen. And every mole of nitrogen. So we're going to go 17.04 equals 83 times 17.04 equals, we have to have 2 significant figures. And what comes out of my calculator is this. But you can't keep that because you have to have 2 significant figures. So the easiest way to write this in 2 significant figures is like that. Okay, so don't use that. Use that one. All right. So you see what you did. You just, whatever you start with, you put that down here, and probably you'll go to the moles. Once you get to the moles, it's easy to get to the grams because that's a 1-to-1 relationship. You're just going to have to add those up to figure it out. Okay? I know some of you are thinking, no, not okay. But it is. It's okay. You're going to be fine.